Hi guys, and welcome to Module 5. Module 5 was on decimals. This module started off with estimating quotients, and quotient is a division word. This problem states a local zoo had a total of 98,464 visitors last year. The zoo was open every day except for 3 holidays, so that's a major clue there. On average, about how many visitors did the zoo have each day? A couple things going on here. Very important information is the fact that the zoo had a total of 98,464 visitors last year. Also important was that the zoo was open every day except for 3 holidays. So since there are 365 days in a year, we would subtract 3 from that, and so the zoo was open 362 days. On average, about how many visitors did the zoo have each day? What we need to do is we need to divide the total number of visitors by the days that it was open, and that will help us answer the question. We're going to start by estimating, and estimating will definitely help us because once we get our answer, we'll be able to determine whether we are on the right track. We're going to start with 98,464, and we're going to think about whether that is closer to 90,000 or 100,000. You always, when you're estimating, want to round to the highest place value. And so if we put 98,464 on a number line, that would be closer to 100,000. So our estimate there is 100,000. And we're going to divide that by, we said 365 days of the year. It was open every day except 3 holidays. So it was open 362 days. Again, we think about the highest place value, which is the hundreds place. 362, is that closer to 300 or 400? And that's actually closer to 400. Now, a trick with dividing that we talked about in class is we can cancel out zeros if we have equal number of zeros in the dividend and the divisor. So this 0 in the dividend can cancel out with that 0 in the divisor, and this one can cancel out with that one as well. Now we're left with 4 goes into 10. 4 goes into 10 2 times, and we take 8 from 10, which leaves us with 2. We bring down this 0, and 4 goes into 20. 5 times, and that will give us 20. And then we're left with one more 0 that we can bring up. So our estimate is going to be about 250 visitors, and that's what the zoo had each day on average. So we're going to go ahead and do the actual. We're going to take the actual total of 98,464. We're going to divide that by 362. Remember, it was open every day of the year except for 3. We're going to take 362, and we want to see how many times it goes into 984. Now, 3 is going to be too high because that's going to be about 900. So let's take 362 off to the side, multiply it by 2, and see where that gets us. We want to get to 984 without going over. So that 2 times 2 is 4. 2 times 6 is 12. 2 times 3 is 6 plus 1 is 7. So we know that if we go over that, it will be over 900. So we're going to say that 362 goes into 984 2 times. We're going to subtract 724 from 984, and that leaves us with 260. We're going to bring down this 6. And let's think about this. 362, well, times 9 is going to definitely be too high because that'll be over 2,700. So let's try 362. Let's try times 7. And 7 times 2 is 14. 7 times 6 is 42, plus 1 is 43. 7 times 3 is 21, plus 4 is 25. And that looks like it is the right number. We're going to take 2,534, and we're left with 2. We can't take 3 from 0, so that's a 5, and that's 10 minus 3 is 7. So We bring down the 4, and that's a 2. So we know that 362 goes into 724 2 whole times, because we just did that prior. And we go ahead and subtract 724, and our answer here, our actual, is 272 visitors is what the zoo had each day. Is it close to 250? Absolutely close to my estimate, so I know that I'm right. Another slide that we worked on in class looked like this. Is 40 a reasonable estimate of a quotient for 78,114 divided by 192? Explain your reasoning. First and foremost, we're dealing with the word estimate. So we know that we're not going to have to do the actual, but we are going to estimate. So we're going to start with 78,114. Again, we're going to think about rounding it to the highest place value, so the nearest 10,000. And so we think 78,114. If we saw that on a number line, would that be closer to 70,000 or 80,000? And so 78,114 is closer to 80,000. We're going to divide that by 192. We're going to think about that, and we're going to think, again, we're estimating, so we want to round to the highest place value, which is the hundredths place. On the number line, would 192 fall closer to 100 or 200? And it actually would be closer to 200. So we're going to set this up. Let's go ahead and put our dividend, 80,000 divided by 200. We're going to do our little trick. We're going to cancel out the 0 from the dividend and the divisor, as many as each one has. We're now left with 2 goes into 8 4 times, because 4 times 2 is 8. And I have 2 zeros that I need to bring up. So my quotient is actually about 400, which is 10 times bigger than 40. So no, this is not a reasonable estimate. We went ahead and created this place value chart in our spirals, and the purpose was to determine the difference between our whole numbers and our pieces. We talked about our number system being based on the number 10. We talked about the number decimal coming from 10, and my Spanish speakers, you know that means 10. So a very interesting fact that we talked about is that our number system, when we're going on the place value chart to the left-hand side, we are getting 10 times bigger. So we see the number 1 in the ones place. If we get 10 times bigger than that, 1 times 10 would be 10. If we're getting 10 times bigger than that, 10 times 10 would be 100. 10 times bigger than that would be 100 times 10, which would be 1,000. And lastly, 10 times bigger than that, 1,000 times 10 would be 10,000. And so when we're going left on the place value chart, we are getting 10 times bigger, whereas when we're going to the right hand side, we are getting 10 times smaller. So we think about the number 1 and we're getting 10 times smaller, that would be 1/10. We're getting 10 times smaller than that, that would be 1/100th. 10 times smaller than that would be 1,000th. And last but not least, 10 times smaller than that would be 1/10,000th. And so we see that the decimal point, every time we see it, we clearly need to know that that separates our whole numbers, which when we're going on the left-hand side, our numbers are getting 10 times bigger. And on the right-hand side, our numbers are getting 10 times smaller. We'll now talk about adding and subtracting decimals, and we're going to start with estimating first. We're going to go ahead and take a look at 1 and 459 thousandths. When we estimate, we want to take a look at the whole number 1. We're going to take a look at the guy next door, and if he is 5 or more, we raise the score, so the 1 would become a 2. And if he's 4 or less, we'd give him a rest, so the 1 would remain the same. And so since the 10th place is 4 or less, we're going to give him a rest, so that stays 1. And then we're going to do the very same thing with 23 and 7/10. We're going to look at the whole number. That number is either going to change, go up by 1, or stay the same based on the guy next door. Well, this one, this 7, if it's 5 or more, we raise the score. 4 or less, give him a rest. He is 5 or more, so we're going to make that 23 and 7/10 of 24, and so my estimate is 25. When we do the actual, we want to go ahead and we're going to write our 1 and 459 thousandths. Now, a common mistake is people want to line up the numbers versus line up the decimal point. And when you add and subtract decimals, it is extremely important that you line up your decimal point. And that's where you're going to determine where your numbers will go. Because adding and subtracting decimals are all about lining up your decimal point first, putting the numbers in their right place value, and then doing the adding and subtracting. So in this case, we have 23 whole, which means we have a 3 in the ones place and a 2 in the tens place. We then have a 7 in the tenths, and this hint right here tells us we need to insert 0 so that both numbers have the same number of decimal places. A lot of times we get weary if we see these empty gaps right here, and so we are given the suggestion of just putting placeholders or just zeros there. So this is an addition problem, and so we now are going to make sure that we line up our decimal points like soldiers, and now we can do our adding. 9 plus 0 is 9, 5 plus 0 is 5, 7 plus 4 is 11, carry the 1, that's 3, 4, 5, and then we bring down the 2. Now our answer is 25 and 25 whole and 159 thousandths, which are tiny, tiny, tiny pieces. And so is this close to whole number 25? Absolutely close to my estimate, so I know that I'm right. When we subtract decimals, we're going to treat this the very same way. When we estimate, we're going to go ahead and take a look at the whole number 21, look at the guy next door, 5 or more, raise the score, or 4 or less, give him a rest. He is clearly 5 or more, so this 21 and 9/10 becomes a 22. We're going to do the same thing with the 1 and 605 thousandths. The 1 is the one that is going to either stay the same or go up by 1 based on the guy next door. If it's 5 or more, you raise the score. 4 or less, give him a rest. Well, he is 5 or more, so we're going to turn this 1 and 605 thousandths into 2. And so our estimate is going to be 20. Now we go ahead and we're going to write the actual 21 and 9/10. Now, when we subtract 1 and 605 thousandths, again, a common mistake would be to place the 1 under the 2, the 6 under the 1, and the 0 under the 9. But that would be incorrect because we would not be placing them in the right place value. So we always want to start by lining up the decimal point. That will now help guide us. There is a 1 in the ones place, whole number side, but the rest goes over to the decimal side or the pieces. There's a 6 in the tenths, a 0 in the hundredths, and a 5 in the thousandths. Again, for those people who don't like those empty spaces, take a look at our hints and tips. We're going to insert the 0 so that both numbers have the same number of decimal places. So we can go ahead and just add some placeholder zeros here. We can't take, and we go ahead and we do the subtraction. This is a minus problem. You can't take 5 from 0, so we go next door and we borrow, and we can't, but we try. So we need to keep that in mind. Therefore, the 9 becomes an 8. Since this 0 we attempted to borrow from him, he becomes a 9, and the last number is a 10. So 10 minus 5 is 5, 9 minus 0 is 9, 8 minus 6 is 2. Make sure you line up your decimal points. 1 minus 1 is 0, and then you bring down your 2. My answer, my actual, is 20 whole and 295 thousandths, which is very close to my answer, my estimate of 20 whole. So I know that I'm right. Now we're going to apply what we know about adding and subtracting decimals in this real world problem. Your meal at the school cafeteria costs $3.45. That's important. Your friend's meal costs $3.90. You pay for both meals with a $10 bill. How much change do you receive? This is actually going to be a two-step problem. The first step is you need to figure out how much yours and your friend's meal is going to cost because you are paying for both. So you're going to take your meal, which is $3.45. To that, you're going to add your friend's meal, which is $3.90. And that gets us a total, make sure you line up your decimal point, of $7.35. Now your step 2, because had it just asked how much is yours and your friend's meal altogether, that would have been the final answer. However, what it's asking is, I paid for both meals with a $10 bill. How much change are you going to receive if you do that? So you handed the cashier a $10 bill, which is what you start with. From that, you're going to subtract the cost of yours and your friend's meal, which is $7.35. Very important that you line up your decimal points here. And we're going to go ahead and subtract 5. You can't take it from zeros, so you go next door. You attempt to borrow. You can't, but you tried. You do it again. You attempt. It's a 0. You can't, but you tried. So this becomes a 0. All of these are 9s because we attempted to borrow from these zeros, and the last one is a 10. So 10 minus 5 is 5. 9 minus 3 is 6. We line up these decimal points. 9 minus 7 is 2. And so my answer is, my change that I receive after I handed the cashier a $10 bill is $2.65. We also talked about multiplying decimals with whole numbers, and we talked about how this is very, very simple. We're not going to let or allow the decimals to confuse us in any way. We are going to multiply as we normally would, and then we're going to take care of the decimal at the end. So we would multiply as we would with whole numbers. In this first example, we have 13 and 91 hundredths times whole number 7. So all they did is they took the 7, multiplied it by the 1, by the 9, by the 3, by the 1, like we normally would. And then when you have your product, your digits would be 9737. But then is when you have to worry about placing the decimal point, which is actually going to be 2 places away, and your answer would then be 97 and 37 hundredths. They gave us a further example with 6 and 218 thousandths that now has 3 decimal places times whole number 4. You're going to treat it the very same way. You're going to multiply the 4 times the 8 times the 1 times the 2 times the 6. And then once you end up with your digits 24872, you're going to count over 1, 2, 3 places with your product. And your answer would then be 24 and 872 thousandths. So the key here is just multiply as you would with whole numbers, and then don't worry about the decimal point until the end. So let's try that. We're going to take 87 times 5, and 5 times 7 is 35, carry the 3. 5 times 8 is 40, plus 3 is 43. I'm going to now worry about the decimal point, which was only 1 decimal place away, and so my answer here is 43 and 5/10. Let's try another one. With this one, 6 times 91 hundredths, since 91 hundredths has the larger number of digits, I'm going to go ahead and put him on top, 91. I'm not going to worry about the zeros. I'll multiply that by 6 as if I were multiplying just whole numbers, and then I'll worry about the decimal point at the end. So 6 times 1 is 6, 6 times 9 is 54. Now that I have my product, I can worry about the decimal point. I'm actually 2 places away. And so in my product, I go 1, 2, and my answer is 5 and 46 hundredths. Okay, we're going to go ahead and we're going to try some. We're going to estimate first, and then we're going to let that guide us towards our actual answer. So we have 5 and 9/10. Again, we're going to look at the whole number of 5. Look at the guy next door. If he's 5 or more, we raise the score. 4 or less, we give him a rest. Well, he actually is 5 or more, so the 5 and 9/10 becomes a 6. I'm going to leave times 11 because I know my 11s, and 6 times 11 is 66. So my estimate is going to be 66, which means my actual should be very close to that. I'm going to go ahead and multiply 5 and 9/10 times 11. Again, not even worrying about that decimal point until the end. 1 times 9 is 9. 1 times 5 is 5. I'm done with this place. And so I'm going to add a 0 because I'm going on to my tens place. So 1 times 9 is 9. 1 times 5 is 5. These are partial products, and they're partial products because it's partly the product that I got when I multiplied the ones place and the tens place. So I'm going to go ahead and add these partial products together. 9 plus 0 is 9. 9 plus 5 is 14. Carry the 1. 5 plus 1 is 6. And now I worry about the decimal place, which is 1 over. So my answer is 64 and 9/10. Very close to 66, so I know that I'm right. Let's go ahead and try the next one. We have 19 and 6/10. Again, we're going to estimate first, so we're going to look at the whole number 19. Look at the guy next door. 5 or more, raise the score. 4 or less, give him a rest. Well, he's 5 or more, so the 19 and 6/10 becomes 20, and I'll leave the 2 the same. So 20 times 2 is 40. My estimate is going to be 40, so my actual answer should be very close to that. I'm going to go ahead and do 19 and 6/10 times 2. Again, not worrying too much about that decimal point until the end. 2 times 6 is 12. 2 times 9 is 18, plus 1 is 19. 2 times 1 is 2, plus 1 is 3. And I have 1 decimal place that I have to worry about. And so my answer is 39 and 2/10. Close to 40, very close. I know that I'm right. Now, what happens when you have to insert zeros in the product? It really is not difficult at all. Again, those zeros are there and they will confuse us if we allow them to. We're just going to follow the rule. The rule says multiply these numbers as if they were whole numbers. Okay, so I'm going to take 16. I'm going to multiply that by 3. 6 times 3 is 18. Carry the 1. 3 times 1 is 3, plus 1 is 4. Now that I have my product, I can now worry about my decimal place. And simply, I will go ahead and count 1, 2, 3. And all this is saying is I have to count 3 decimal places over, but I only have 2 numbers. So that means that I'm going to go ahead and insert a 0 so that I can correctly have an answer of 48 thousandths. Let's go ahead and try another. Again, I'm going to disregard those zeros. I'm going to disregard that decimal point. I'm just going to go 12 times 8, and I know that that's 96. And now I'm going to go ahead that I have my product and worry about the decimal places. So I'm counting 1, 2, 3 decimal places over. 1, 2. Well, I need 1 more, so I'm going to insert that 0 and put my decimal point. My answer is 96 thousandths. I'm going to do the same thing with this one, and you'll see that it becomes very, very simple once you just keep it in your mind that all you have to do is multiply your numbers as usual, 3 times 3, as if they were whole numbers, get your product, and then you worry about your decimal point. And so we're going to count over 1, 2, 3 places over, 1, 2, 3. In this case, we have to add 2 zeros, and the answer here is 9 thousandths. Now, what happens when we multiply decimals by decimals? And this is pretty simple, and it becomes a lot of fun because when you're multiplying a decimal by a decimal, not much changes in that you still multiply as you would with whole numbers. The only difference now is you would add up and you would sum the total number of decimal places. So in this case, for example, we have 4 and 716 thousandths, which has 3 decimal places, times 2/10, which has 1 decimal place. So once you have your product, your digits would be 0, 9, 4, 3, 2. You would now have to determine, well, how many decimal places do I have to count over? And in this case, you would add the total sum of all of them. So 1, 2, 3. There's actually 4 total decimal places. And so in your product, you would count 4 decimal places, and your answer would be 9,432 10,000ths. Okay, let's apply what we have learned about multiplying decimals with this real world situation. So I am at the supermarket and I'm buying 2 7/75 pounds of tomatoes. I hand the cashier a $10 bill. How much change will I get back? Well, a couple things going on here. First and foremost, I don't really want to concern myself with the grapes or the bananas. I'm really just concerned about the tomatoes at $1.89 a pound. My step 1 is if I purchased 2 7/75 pounds of tomatoes and they were at $1.89 a pound, I would multiply 2 7/75 times 1 89/100. Now I'm going to go ahead and multiply these numbers as if they were whole numbers. I'm not going to worry about the decimal point until the end. So 9 times 5 is 45, 9 times 7 is 63, plus 4, 64, 65, 66, 67. 9 times 2 is 18, 19, 20, 21, 22, 23, 24. I'm done with this, so I'm going to get rid of the carries, and I'm going to put my 0 to go on to the next place. So 8 times 5 is 40. 8 times 6 is 56 plus 4, 57, 58, 59, 60. 8 times 2 is 16, 17, 18, 19, 20, 21, 22. Just got to make sure that you spread out your numbers. Now I'm done with that place. So since I'm going on to my third place over, I have to add 2 zeros. And now I go 1 times 5 is 5. 1 times 7 is 7. 1 times 2 is 2. All of these partial products I'm going to add together. So 5, 7, 9, 11, 5. Now my digits are 5, 1, 9, 7, 5. Really, if I don't concern myself with the decimal point, I'm thinking, did I really spend $51,975 on tomatoes? Well, that doesn't make sense. So I know that I forgot to bring over my decimal places. So I go ahead and count the total number of decimal places. That's 1, 2, 3, 4. So I go 1, 2, 3, 4. Now, when I'm at the cashier, I have to think about this logically. She's not going to tell me, well, you owe $5 and 1,975 ten thousandths, because we don't have coins that small. What she's going to say is I owe $5 and either 19 cents based on the thousandths place, or she's going to say I owe $5.20 based on the guy in the thousandths place, because our smallest coin is the hundredths place. So when I go to the cashier, they're going to charge me either $5.19 based on the thousandths place or $5.20. And if he's 5 or more, we raise the score. If he's 4 or less, you give him a rest. Well, clearly he's 5 or more. So what I really spent was $5.20 on the tomatoes. But I'm not done there, because the rest of the question says if I hand the cashier a $10 bill, how much change will I get back? So let's go ahead and work on step 2. We're going to subtract the $10 that we handed the cashier. We're going to make sure that we line up those decimal points minus the cost of the tomatoes, which is $5.20. We're going to go ahead and 0 minus 0, 0. We can't take 2 from 0. We tried to borrow from the guy next door, but we couldn't, but we tried. So this is a 0. This becomes a 9. He now becomes a 10. 10 minus 2 is 8. Make sure you line up your decimal points like soldiers. 9 minus 5 is 4. And so my answer is $4.80 is what I would get back. So this was a 2-step problem. Now, a very similar problem, if we buy 3 2/10 pounds of bananas and they cost $2.74 per pound, we pay with a $10 bill, how much change will we get back? Again, 2-step problem. Let's start with step 1. Step 1 is to take the amount of each pound times the amount of pounds that I purchased. Since 2 7/400 has the most digits, I'm going to put that number on top. And then I'm going to multiply that by 3 2/10. I am not going to worry about those decimal points yet. I'm just going to multiply the numbers as if they were just whole numbers. So 2 times 4 is 8. 2 times 7 is 14. Carry the 1. 2 times 2 is 4 plus 1 is 5. I'm done with that place. And so I'm going to go ahead and put a 0. I'm on to my next one. 3 times 4 is 12. 3 times 7 is 21 plus 1 is 22. 3 times 2 is 6 plus 2 is 8. These are partial products. I'm going to go ahead and add those together. 8, 6, 7, 8. Now is the time when I have to worry about the decimal point. So let's see. We're going to count 1, 2 from the 2 7/400 plus another decimal place from the 3 2/10 pounds. So that's a total of 3 decimal places. And so cashier is going to tell me you owe $8.76 based on the thousandths place, or $8.77 based on the guy next door. Well, he's 5 or more. So we're going to go ahead and raise the score, and that means that we spent $8.77 on bananas. Now, we are not done, because the question asks if we pay with a $10 bill, how much change are we going to get back? So we're going to go on to step 2. Let's represent the $10 that we handed the cashier. We start with that. And from that, we subtract the cost of the bananas, which was $8.77. Now we can't take 7 from 0. We attempt to borrow from the guy next door. We can't, but we tried, and we're going to continue doing that till we get to this number. They're all going to be 9s because we attempted to borrow from them, and the last one is a 10. So 10 minus 7 is 3. 9 minus 7 is 2. Make sure you line up those decimal points. 9 minus 8 is 1. And so our answer is we would get $1.23 back. Now we move on to dividing decimals by whole numbers. And the rule says when you have a decimal in the dividend, all you have to do is simply bring up that decimal point into your quotient or your answer, and then you would divide as normal. So in this case, we have 7 and 32 hundredths. We bring up that decimal point, and then we would divide 4 into 7 and 32 hundredths. Okay, let's go ahead and practice dividing these decimals. We're going to estimate first. We're going to look at the whole number 7. We're going to look at the guy next door. If he is 5 or more, we raise the score. 4 or less, give him a rest. Well, he's 5 or more, so we're going to turn the 7 and 6/10 into 8. Divided by, we're going to keep the 4 the same. So our estimate is going to be 2, and so when we come up with our actual, it should be very close to 2. Let's go ahead and take our dividend, 7 and 6/10, and let's divide that by 4. The rule says you bring up that decimal point from your dividend into your quotient, and now you just divide as normal. So 4 goes into 7 one whole time. 4 times 1 is 4. You take that from 7, that is a 3. You bring down your 6, and 4 goes into 36 9 whole times. 4 times 9 is 36. 1 and 9/10, very close to 2, so I know that I'm right. Now let's apply what we know about dividing decimals in this real world problem. We have a high school track. It's 9 and 76 hundredths meters wide. It's divided into 8 lanes of equal width for track and field events. How wide is each lane? Important information is that each lane has equal width, and that means that we can divide because it's equal parts. And so we also need to know, and it's important, that the track is a total of 9 and 76 hundredths meters wide. Well, that's going to be our dividend. He's the total that we're dividing by 8 lanes. And we want to know how wide each lane is. Rule number 1 is we're going to bring up this decimal point from the dividend, and now we're just going to divide as normal. So 8 goes into 9 one whole time. We take 8 from 9, and that's 1. Bring down the 7. 8 goes into 17 2 times. 8 times 2 is 16. And 17 minus 16 is 1. Bring down your final 6. And 8 goes into 16 2 whole times. And so our answer is each lane is 1 and 22 hundredths meters wide. Now, what happens when we have to divide a decimal by a decimal? And this is pretty simple. We really need to always just keep in mind that our divisor, the number on the outside, could never be a decimal. And so as you see in the slide, if the divisor has a decimal, you're going to make him 10 times bigger by turning him into a whole number. So you move that decimal place as many times as you need to in order to make him a whole number. The key also is whatever you do to the divisor, you must do to the dividend. So in this case, when we started with 4 and 56 hundredths and we divided by 1 and 2/10, well, we knew that we had to move that decimal point over because the divisor could not be a decimal. He had to be a whole number. So to make him a whole number, we moved him over 1 time. We made him 10 times bigger. What we did with the divisor, we must do to the dividend as well. And so this decimal point now came after the 5. And so now our new setup is 45 and 6/10 divided by 12. Now that we have the divisor as a whole number, we can go ahead and divide as normal. We would bring up that decimal point and then divide 12 into 45 and 6/10. Okay, so let's go ahead and try this one. Our dividend is 18 and 2/10, and we're going to divide that by 1 and 4/10. Now the rule says this divisor could never be a decimal. So we're going to move him over. We're going to make him 10 times bigger to make them a whole number 14. So the new setup is 14, but remember, what we do to the divisor, we must do to the dividend as well. So the decimal point is going to end up over here, which means that's just a whole 182. So 14 goes into 18 one whole time. Take 14 from 18, and that'll give you 4. Bring down the 2. And 14 times 3 is exactly 42, and so the answer here would be 13. Now this slide shows us sometimes we're going to have to insert zeros in the dividend and the quotient because, for example, if we have 7 thousandths and we're trying to divide it into 2 and 45 hundredths, we had to move it over 1, 2, 3 times in order to make it a whole number 7, as you clearly see here. So if we did that to the divisor, we had to do the same thing to the dividend, and so when we counted over 3 times, there was that empty spot there, and you had to insert a 0. Let's apply our knowledge of dividing decimals in this real world problem. So Ella uses 5/10 pounds of raspberries in each raspberry cake that she makes, and they want us to determine how many cakes can she make with 3 and 25 pounds of raspberries. So the very first thing that we need to think about is, who is our dividend? Well, our dividend is the number that we have total that we are going to divide. Well, she has 3 and 25 pounds of raspberries, and we're going to divide that by each cake requires 5/10 of a pound. Well, the rule says that that divisor could never be a decimal, so we're going to move him over 1 time. We're going to make him 10 times bigger to make him a whole number 5. What I do to the divisor, I must do to the dividend, so the decimal point is going to end up right there. So our new setup is 5 into 32 and 5/10. Well, now we know what we need to do. We need to bring up this decimal point into our quotient, and now we're going to divide as normal. So 5 goes into 32 6 times, and we take 30 from 32. That gives us 2. Bring down the 5, and 5 goes into 25 5 whole times. So in this example, Ella could make 6.5 cakes with 3 and 25 pounds of raspberries if each raspberry cake required 5/10 of a pound. Okay, let's go ahead and try another. So Anthony spent $11.52 for some pens that were on sale for 72 cents each. How many pens did Anthony buy? Well, we know that he paid the same amount for each pen. So what we can do is take the total amount that he paid, $11.52, and divide that by the cost of each pen, and that will let us know how many pens he purchased. Now, we do understand that the divisor could never be a decimal, so we're going to move him 1, 2 times, so we have made him 10, 100 times bigger. And so he is now 72 divided by what I do to the divisor, I must do to the dividend. So I'm going to go ahead and move this one 2 times over as well. So now this becomes 1,152 divided by 72. Well, 72 goes into 115 one time. I know I can't go higher than that, so I take 72 from 115, and that gets me 43, bring down the 2, and 72, think of a number that when I put here is going to give me a 2 here. I'm going to try 6. 6 times 2 is 12. 6 times 7 is 42, plus 1 is 43. Yep, and that is excellent. So that goes into 432. 6 whole times exactly, and so Anthony purchased 16 pens. We also talked about in class the importance of the difference between a terminating decimal and a repeating decimal. We understand that this fraction bar really means divide, and if we divided 1 divided by 2, we would get a half, 5/10, or 50 hundredths. That's a terminating decimal because he ends. Now, contrastly, a repeating decimal is something like 2/3, where when you divide 2 divided by 3, you end up with a repeating decimal. So a repeating decimal means this 6666666 will go on forever. So we put this bar on top of the number that repeats itself to represent that that is a repeating decimal. This is an extremely important slide because I want us to be able to, when we see a fraction, be able to know that there is a very distinct and interesting relationship between fractions and decimals. And fractions and decimals are interrelated. They are both pieces. And so if you see a fraction, you can instantly turn it into a decimal and vice versa. So we should at this point understand that this fraction bar means divide. We should also remember that the denominator, remember dog, D and D, goes on the outside, and the numerator is the dividend. He goes on the inside. And you go, well, 8 can't go into 1, and you're absolutely right. It can't go into it whole time, so now we know that we're talking about decimal pieces. This is where you introduce your decimal point. This is where you start adding zeros until you reach either a terminating decimal or a repeating decimal. 8 goes into 10 one whole time. If I take 8 from 10, I get 2. I'm going to keep adding zeros until I reach either a terminating decimal, one that ends, or a repeating decimal, one that repeats. 8 goes into 20 two times, and I take 16 from 20, and I get 4, and I'm going to keep adding zeros until I reach either a terminating or repeating decimal. 8 goes into 40 5 whole times, and I subtract 40. And so what this is proving is that 1/8, the fraction, is equivalent, equal to, the same as 125 thousandths. Let's go ahead, and this is a terminating decimal because he ended at 125 thousandths. Let's go ahead and do the same thing with 5/6, again, knowing that this means divide. The denominator goes on the outside, the numerator goes on the inside. He's our dividend. 6 cannot go into 5 whole times, so that means these are going to be pieces, and we introduce decimal point and zeros. 6 goes into 50 8 times, and I take 48 from 50, and I get 2. And I continue adding zeros until I get either a terminating or repeating decimal. 6 goes into 20 3 times, and I take 18 from that, and I end up with 2, and I keep adding zeros, and 6 goes into 20 3 times, and I take 18 from 20, and I get 2, and I keep adding zeros. Hopefully by now you notice that this is going to end up being a repeating decimal because the 3 is repeating itself. And so in this case, 125 thousandths would be a terminating decimal because he ends. And 5/6 is a repeating decimal because 0.833333 will continue repeating itself. Now this is also another very important slide because you need to know how to turn fractions into decimals and vice versa. Now in this slide we have 4 fractions and we're asked to turn them into decimals, and we are asked to determine whether they are terminating or repeating decimals. Well, I'm going to give you a very great trick, hint, and tip. If your denominator is a denominator that can be turned into tenths, hundredths, or thousandths, then we don't have to sit there and do the division that we just did in the previous slide. Let me explain further. Remember decimals, and if you remember on the place value chart, the place right after the decimal point, that first place is the tenths place. Then we have the hundredths place and the thousandths place. So if we're turning these fractions into decimals, and they are ones that we can turn either to tenths, hundredths, or thousandths, then we don't have to sit there and divide. We could very well divide and end up with the same answer. But it's just a quick tip where, for example, this 3/5, if we wanted to turn that into a decimal, okay, we can do the equivalent of a fraction of 3/5 and turn it into tenths. And so 5 times what number will give us 10? That'll be 2. What I do to the denominator, I do to the numerator. And so that means that 3/5 is the same as 6/10. If we write that as a decimal, that would just be decimal point 6 in the tenths place. We can do that also with 9/20. That one we can't turn into tenths, but we can turn them into hundredths. And again, we can do that because the decimal places say if it's tenths, hundredths, or thousandths, those are decimals. So 20 times what number is 100? Well, that's 5. What I do to the denominator, I do to the numerator. 9 times 5 is 45. So 45 hundredths, the way we would represent that as a decimal is your decimal point, 45 hundredths. And last but not least, we have 8 and 8 fifths. We can turn that into tenths. And we go 5 times what is 10? Well, that's 2. We do that to the numerator. 8 times 2 is 16. And in this one, you say, wait a minute, this is an improper fraction. But it does make sense because we started with an improper fraction as well. And as a decimal, all this simply means is that it is 1 whole and then 6 tenths, 6 in the tenths place. So that's just a quick, easy trick to turning fractions into decimals that have denominators where you can turn them either tenths, hundredths, or thousandths, because that's what our decimal system allows us to do. Now, we wouldn't be able to do that with 1/9 because there's nothing times 9 that'll get me to either 10, hundredths, tenths, hundredths, or thousandths. So we are going to have to divide here, and we understand that the denominator, dog, D and D, goes on the outside, numerator goes on the inside. Let's go ahead. 9 does not go into 1, so we know that we're going to have decimal pieces, and we're going to introduce the 0. 9 goes into 10 one whole time, and we take 9 from 10, and that gets us 1. We're going to add a 0. 9 goes into 10 one time. We take 9 from 10, and that gives us 1. And if you notice, the repeating decimal here is going to be 1, 1, 1, 1, 1, 1, 1. So the 3 fifths, the 9 20ths, and the 8 fifths, those were terminating decimals because they ended. On the other hand, the 1/9 is a repeating decimal because the 1, 1, 1, 1, 1, 1, 1 is going to repeat itself. Now that I explained to you from the previous slide how to turn denominators into tenths, hundredths, or thousandths, this slide is going to be very simple. We're going to go ahead and take 3/20ths, and we know that we can't make that a tenths, but we can make it hundredths, and we go 20 times what will get me 100? Well, times 5. What I do to the denominator, I do to the numerator, and so 3/20ths is the same as 15 hundredths. When you write that as a decimal, you got your decimal point, 15 hundredths. And we'll go ahead and do the same thing here with these fractions. We can easily turn these into decimals without dividing them. We very well can and end up with the same answer. But to save us time, and since we know this quick trick, we're going to go ahead and we can make this 5 8/10ths. And we go 5 times what number is 10 times 2. What I do to the denominator, I do to the numerator. And so 4 times 2 is 8. And 4 fifths is the same as 8/10ths as a decimal. We're going to do the same thing with 7/50ths. This one we can turn into 100. 50 times what will get me 100? What I do to the denominator, I do to the numerator. 7 times 2 is 14. And so 7/50ths is the same as writing the decimal 14 hundredths. Now let's use everything that we know, and let's use this knowledge that we have gathered about multiplying decimals and adding and subtracting decimals and dividing decimals into practice. This question asks, Naomi earned $54 mowing lawns in 2 days. She worked 2.5 hours yesterday and 4.25 hours today. If Naomi was paid the same amount for every hour that she works, how much did she earn per hour? Well, one very important and interesting fact is that she is getting paid the same amount for every hour that she works. So since we know that, we can go ahead and add the hours that she worked yesterday, which was 2 5/10, with what she worked today, which is 4 25 hundredths. Be careful, make sure that you line up those decimal points. And so we can put our imaginary 0 there, and we can add the total number of hours that she worked yesterday and today. Now, total, we line up these decimal points. She worked 6 75 hundredths hours. The next step is we need to determine how much she earned per hour. So why don't we take the total that Naomi earned, which was $54, and let's divide that by the hours, total hours that she worked yesterday and today, which is 6 7/75. Now the rule tells us that we have to take this divisor and we have to turn him into a whole number. So we're going to move that decimal point 2 times. And this one, we're just going to add 2 zeros because he's a whole number, 54. So our new setup is going to be 675 going into 5,400. Okay. Now, I want to, 675 can go into 540. So I need to see how many times it goes into 5,400. So what I need to do is I need to multiply it by a number that when I put it here, it'll give me a 0 because I'm trying to end up with zeros. So let's try 8. 8 times 5 is 40. That's 8 times 7 is 56 plus 4 is 60. 8 times 6 is 48, 49, 50, 51, 52, 53, 54, and that is absolutely perfect. It goes into it evenly, perfect, whole times. And so the answer here, after we added the hours that Naomi worked yesterday and today and got that total and divided that into the money that she made, that will then help us to determine how much she earned an hour. And in this case, Naomi earned $8 an hour. This is a very similar question. In this example, Casey buys 6 2/10 yards of blue fabric and 5 4/10 yards of red fabric. If the blue and red fabric cost the same amount per yard and Casey pays $58 for all of the fabric, what is the cost per yard? So the first thing we need to do, and this is important information, the fact that the blue and red cost the same amount per yard is important, because then we can just add the blue fabric, which is 6 2/10, plus the red fabric, which is 5 4/10, making sure you line up those decimal points. So I know that she has purchased a total of 11 6/10 yards of fabric, both blue and red. Now, in order to determine what the cost per yard was, I can take the total that she paid for all the fabric, which is $58, and divide that by the total yards of fabric that she bought, both blue and red. And the rule says we can't have this divisor as a decimal, so we're going to move him over 1 time, and that means that we can add a 0 here. So our new setup is 116 into 580, and I'm going to go off to the side, and I want to see how many times 116 goes into 580. I'm thinking of a number here that when I multiply it, I'll end up with 0, so let's try 5, and that'll give us 30, that's 8. And that is exactly right. It goes into it 585 whole times. So the cost per yard is going to be $5 per yard, because since everything costs the same amount per yard, we could just add the blue fabric plus the red fabric, and that's a total of 11 6/10. And we divided that by divided that into what she paid for all the fabric, and that let us know how much she paid per yard, which was $5. And this is our final slide. Let's take a look at this question. The bill for a pizza was $14.50. Very important. Charles paid for 3/5 of the bill. Now, how much does Charles pay for the pizza? The first thing that we need to think about is if he pays 3/5 of, that means we're going to multiply, because we want to know what 3/5 of $14.15 is. So we're going to start with $14.50. Of means times 3/5. Now what I have here is a whole number times a fraction. And I know that in order to solve this, I can set this $14.50 over 1 to also make him a fraction but not change his value. I could simplify here and I can say 5 will go into $14.50. Well, let's go off to the side and see how many times 5 goes into $14.50. The first step is we're going to bring up that decimal, and 5 goes into 14 2 times. I'm going to take 10 from 14, that gives me 4, bring down my 5, 5 goes into 45 9 times. And now I just bring up that 0. So 5 goes into 1452 and 90 hundredths. And now I'm left with $2.90 times 3. So I'm going to go over here and work that, because now I just have to multiply the numerator straight across. And that is 0.728, and I count 2 decimal places over, so that's $8.70 over 1 times 1 is 1. So what Charles paid for the pizza, 3/5 of $14.50, is $8.70. This concludes Module 5 on decimals. Any questions, please feel free to ask.